Hi. For workshop C, we want to discuss how to use Node-RED, and we will experiment with the GIoT board that is used that is discussed before in the previous video. Okay, and detail on how to create a display and control uh, using Node-RED is in chapter 8, so you can uh, see this video together with the material in chapter 8 to get started. First of all, you make sure that you have the GIoT board set up and running properly. It can connect to the NetPi, just like the message here, and you can send the JSON string to the NetPi. Okay, to make sure that it works, you can just type some command in the serial monitor. Let's say you want to change signal frequency to something 30, and it should be changed, and then the new value is sent to the NetPi channel. Okay, on NetPi you have two devices. This device is connected to the hardware. Okay, so you use this information to on the SP32 program, and the other one is the device for Node-RED. Okay, you should have these two devices, otherwise you cannot communicate. And the two must be grouped together. I create group one here, group them together. So now the hardware can communicate to Node-RED, and we supply this information to the Node-RED. So you must make sure to set up this properly. You click on this and see that the topic has to be a shadow data updated colon and then the device that is connected to the hardware. Okay, and for the MQTT current ID, you have to put here from the NetPi. Okay, and for that you have to put the information from this one. Okay, from the .NET device currently token secret. Go to currently here and username and password. Okay, that's all. When you deploy this, you will see that the device connect properly. And now I want to see that how the message, how this message look like. Okay, when we light to the shadow, so maybe I can set amplitude to 0.5. You see that. Then and now the device, the message goes into this debug node. Okay, from the MQTT in. It means that the message can be received correctly. Now we only have to extract the frequency, amplitude, and the signal type here from the whole message, and we do that the same way as we did in the lecture 8 video. But before that, I want to test the other way of communication. That is, we want to send the command from this node to the device and make sure that we can do that. So in that case, we use the MQTT out node. Okay, and we want to send the command using the dashboard node. Okay, the text input right there. So let's see how this works. If you click on this, you see that the setup for the NetPi device is remains. Okay, it is safe, so you don't need to do anything with this. But you have to change the topic. The topic to this device. Okay, in the program I set that the topic is @command the topic. Okay, so you put that into the topic right there. And now click on this and do some setup. Okay, SGIoT. Control. Okay. And we don't have to do much on this except that we change the delay to 0, call the name with command. Okay, and let's see if this works. Deploy and see it in the dashboard. See, I have a command like this. See how if the command is sent to this or not. Use the same command just like we type in the serial monitor. Send the signal frequency to 10. Now you see that the message go to the serial monitor. Okay, serial monitor show that the message is received. Okay, the command is received at the topic message. The command frequency equal to 10. So the communication work both way. You can send the command here and you can receive the message in node lane. Okay. See if this works. Amplitude equal to 1. Okay. Now we have the message appear in the debug node. So we are ready to do more stuff with this node later. So I omit the detail of creating this series of split and switch because it is covered in lecture 8. Okay, we do the same thing. So for example, for this split, I split at signal frequency and then switch. Okay, here I split at text signal amplitude, and then I switch here and separate the subsyn to subsyn 0 and 1 to output, and the subsyn 0 go to this message payload and so on. Okay, you can see this detail in lecture 8. I want to see if this works or not. I can command, let's say 6 frequency equal to 5. Now you have the first one, the message payload one is signal frequency. Second one is signal amplitude, and the third one is stick. Now select. Okay, let's change that. Select equal to sine wave. Okay, it is changed properly. Test it with the shift amplitude. The amplitude equal to 5. Okay, so things works properly now. The next step is we only have to change this method payload node to the gauge because you want to display it using the gauge. Or maybe if you don't want to use the gauge, you can use this feedback to the command. Okay, because you want to use some widget on the command node. Okay, to adjust the value of the frequency, the amplitude, and use the switch to select the signal. Okay, so let's do that. So from the previous flow, we have changed it like this. We replace the debug node with this control. Okay, we use the frequency slider for the amplitude and frequency adjustment, and use the drop down node. Okay, to select the signal, and we do the same thing as in lecture 8 to update the control. Okay, and send it to the MQTT out like this. So we want to see how this works. So let's go to this screen here. Okay, I rearrange it a little bit to just for you to see. Okay. So here is the scope. And you see that when we adjust the frequency, the frequency increase, so it seems to work okay. I can change the signal type. Okay. And the amplitude. It seems to work quite well, right? But there is some problem, but I will show you after I set this for some time. Okay. If you click it clean like this, it's quite okay. But when you drag it like this, and sometimes it cause problem. Okay. Now, after I attach this for a little while, you see that there is some like a looping in here, and the signal amplitude is switch between two values. Okay, when it send to point 8, it is updated to point 9, then it going on and on like this. So you see that there's a unstable problem with this. So we need to fix this because in actual use you don't have to adjust this quite frequently, like so we can limit the rate of sending the command from the node RED to the program RED. Previously in the program we see that this function callback is the one that receive message from the netpy or node RED and check that if the topic is add message command here, you call the command interpreter immediately, right? So whenever the command comes through this function, it is it invokes the command interpreter. So we fix this to a new program here. So just delay it. Okay, we check that the system time and check that if the command come too frequently, we don't invoke the command interpreter. So we have to wait by setting this variable to some value, say 2 seconds. So you cannot set a command more frequent than 2 second interval. Okay, and here I download it to the board and see if it improve. Okay, so we check our program here and try to adjust things like before. Okay, so we move this quite widely to see if there is still that kind of infinite loop. Okay. And that problem seems to be eliminated by our quick fix. See, there's no looping exists after I test this quite widely for some time.